Hello everyone. In the beginning of the class, please pause the video, review all these problems first. After you finish doing these problems, you can continue the video and I will show you all my work in detail. Okay, let's work together for these problems. First problem. Graph the line. Passing through points 1, -3 and 3, 1. And find the slope of the line. So first step, let's sketch the graph first. In a plane, we call a horizontal line x-axis. We call a vertical line the y-axis. 0 is in the middle. Numbers to the right are positive. 1, 2, 3, 4. Numbers to the right are positive. 1, 2, 3, 4. Numbers to the left are negative. -1, -2, -3, -4. Numbers above 0 are positive. One, 2, 3. Numbers below 0 are negative. -1, -2, -3. Let's plot these 2 points first. 1, -3 means x-axis, x coordinate is 1. Y coordinate is -3. It's here. Let's first point 1, -3. Second point 3, 1. X coordinate is 3, Y coordinate is 1. X coordinate is 3, Y coordinate is 1. That's the second point. 3, 1. So first point 1, -3. Second point 3, 1. 3 represents X coordinate, 1 represents Y coordinate. For the first point, 1 represents X coordinate, -3 represents Y coordinate. Then connect 2 points, we can make a line. By connecting 2 points, we can make a straight line. By connecting 2 points, we can make a straight line. And that's the graph of the line passing through these 2 points. Next, find the slope of the line. Find the slope of the line. When we find the slope, we treat the first point as x1, y1. We treat the second point as x2, y2. Slope of the line is y2 minus y1 over x2 minus s1. Then plug in the values. y2 minus y1, we have 1 minus -3. y2 minus y1, 1 minus -3. x2 minus s1, we have 3 minus 1. Then the numerator 1 minus -3 can be rewritten as 1 plus +3. When we change subtraction to addition, changing the sign of the second number. In the bottom, 3 minus 1 is 2. On the top, 1 plus positive 1 plus +3 is 4. 4 over 2 is 2. So the slope of this line is 2. Next, graph the line. Passing through points -2, 2 and 1, -1, and find the slope of the line. So first of all, let's draw the x and y axis first. In the coordinate plane, we call the horizontal line the x-axis. We call the vertical line the y-axis. Let's label the point first. We have 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. First of all, let's plot the points -2, 2 and 1, -1. -2, 2 means x coordinate is -2, y coordinate is 2. First number always represent x coordinate, and the second number always represent a y coordinate. -2, 2. X coordinate is -2, y coordinate is 2. And the point is here. X coordinate is -2, y coordinate is 2. That's the point -2, 2. The second point 1, -1. 1, -1 means x coordinate is 1, y coordinate is -1. X coordinate is 1, y coordinate is -1. That's the point. X coordinate is 1, y coordinate is -1. So that's the point. 1, -1. Then by connecting 2 points, we can make a line. Connect 2 points together, we can make a straight line. And this is the graph of the line. This is the graph of the line. Next, find the slope. Formula for slope is y2 minus y1 over x2 minus x1. Usually we call the first point s1, y1. We call the second point x2, y2. Then use the formula. y2 minus y1, -1 minus 2. y2 minus y1, -1 minus 2. Over x2 minus s1 over 1 minus -2. Then the top can be rewritten as -1 plus -2. If we think of combining like terms, -1 minus 2, we can consider as -1 plus -2. The bottom, when we convert subtraction to addition, I can write it as 1 plus +2. When I change subtraction to addition, I change the sign of the second number. Negative become positive. Then on the top, -1 plus -2. When we are adding 2 numbers with the same sign, keep the sign, add the magnitude. 1 plus 2 is 3. And on the bottom, 1 plus 2 is 3. Then -3 divided by +3. Negative number divided by positive number, the answer is always negative. 3 divided by 3 is 1. So the slope is -1. Next, graph the line. Passing through point 2, 4 with the y-intercept -2 and find the slope of the line. Let's sketch the graph first. Graph the line passing through point 2, 4 and with y-intercept of -2. Let's sketch the graph first. In the coordinate plane, there are two lines. Horizontal line is called the x-axis. Vertical line is called the y-axis. 0 in the middle, number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Plot the point first. First point 2, 4. First number represents x coordinate. Second number represents y coordinate. When x coordinate is 2, y coordinate is 4. That's the point 2, 4. X coordinate is 2, y coordinate is 4. And the y-intercept is -2. When the y-intercept is -2, means the line goes through -2 in the y-axis. If the y-intercept is -2, that means the line goes through -2 in the y-axis. Then by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. Use a ruler, it will be better. By connecting 2 points, we can make a line. If we use ruler, it will be better. That's a graph. Next, let's try to find a slope. Formula for slope is y2 minus y1 over x2 minus s1. And we can call the first point s1, y1. We can call the first point s1, y1. How do we find the second point? Second point, we know the y-intercept is -2. If the y-intercept is -2, that means this point located in the y-axis. For the point in the y-axis, the s-coordinate is always 0. For the points in the y-axis, the s-coordinate is always 0. So this point can be labeled as 0, -2. For any point in the y-axis, the s-coordinate is always 0. So this point can be written as 0, -2. So if y-intercept is -2, we have a point 0, -2. If the y-intercept is -2, we have a point 0, -2. Then we call the first point x1, y1. We call the second point x2, y2. We call the first point s1, y1. We call the second point x2, y2. Then use the formula. Slope is y2 minus y1 over x2 minus s1. y2 minus y1, -2 minus 4. Over x2 minus s1, 0 minus 2. The top can be rewritten as -2 plus -4. We try to convert subtraction to addition. The top can be rewritten as -2 plus -4. Bottom can be rewritten as 0 plus -2. So on the top, when we are adding two numbers with the same sign, keep the sign, add the magnitude. On the bottom, 0 plus -2 is -2. 0 plus every number, the number stays the same. If 0 plus any number, the number stays the same. Then let's divide. When we divide two numbers of the same sign, answer is positive. 6 divided by 2 is 3. So the answer is positive 3. So the slope for this line is 3. Next. Graph the line. Passing through point -1, 2 with the x-intercept with the x-intercept 3, and find the slope of the line. Find the slope of the line. Graph the line first, then find the slope. Let's first of all draw the x and y axis first. Let's draw x and y axis first. In the coordinate plane, we call the horizontal line x-axis. We call the vertical line y-axis. Zero in the middle, numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then we plot the points. First point, -1, 2. -1, 2 means the x coordinate is -1, y coordinate is 2, x coordinate is -1, y coordinate is +2. So that's the point, -1, 2. X coordinate is -1, y coordinate is 2. That's the point, -1, 2. X coordinate is -1, y coordinate is 2. Then next, we know that the x-intercept is 3. That means the line goes through 3. The line goes through 3 in the x-axis. X-intercept is 3, means the line goes through 3 in the x-axis. Connect 2 points, we can make a straight line. By connecting 2 points, we can make a straight line. By connect these 2 points, we can make a straight line. And that's the graph of this line. By connecting 2 points, we have a straight line. That's the graph of the line. Next, we try to find the slope of the line. The formula for slope is y2 minus y1 over x2 minus s1. We call the first point s1, y1. Here we don't have a second point, so we try to find the second point using the x-intercept. X-intercept is 3. For any point in the x-axis, the y-coordinate is always 0. For any point in the x-axis, the y-coordinate is always 0. So this point can be labeled as 3, 0. For any point in the x-axis, the y-coordinate is always 0. So this point can be labeled as 3, 0. So x-intercept is 3. X-intercept is 3. That means the point in the x-intercept, is 3, 0. X-intercept is 3 means the point in the x-intercept is 3, 0. For the point in the x-axis, the y-coordinate is always 0. So 3, 0. We call the first point s1, y1. Then we call the second point x2, y2. Then plug into the formula. Plug the point to the formula. y2 minus y1. We have 0 minus 2. y2 minus y1 over x2 minus s1 over 3 minus negative 1. y2 minus y1 over x2 minus s1. Then the numerator can be rewritten as 0 plus negative 2. We convert subtraction to addition. The denominator can be rewritten as 3 plus positive 1. Convert subtraction to addition. Then on the top, 0 plus negative 2 is negative 2. 0 plus any number, that number stays the same. 3 plus positive 1. Positive 3 plus positive 1 is positive 4. Then negative 2 divided by positive 4. Negative number divided by positive number means the answer must be negative. 2 over 4 can be reduced. 2 over 4 is not divisible, but it can be reduced. 2 over 4, I can divide top and bottom by 2. It can be reduced as 1 over 2. That's the slope of the line. Next, graph the line passing through points negative 3, 2 and 4, 2 and find the slope of the line. Find the slope of the line. Graph the line, then find the slope of the line. First of all, sketch the graph first. Plot the point first. Plot the point. Sketch the graph first. In the coordinate plane, we call the horizontal line the x-axis. We call the vertical line the y-axis. 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's plot the point first. Negative 3, 2. When x is negative 3, y is 2. When x is negative 3, y is 2. That's the point, negative 3, 2. When x is negative 3, y is 2. That's the point, negative 3, 2. Second point, 4, 2. When x is 4, y is 2. When x is 4, y is 2. That's the second point, 4, 2. When x is 4, y is 2. Then connect 2 points, we can make a line. Connect these 2 points, we can make a line. Connect 2 points, we can make a line. That's the graph of the line. Next, find the slope. Formula for slope is y2 minus y1 over x2 minus s1. Then, usually we call the first point s1, y1. We call the second point x2, y2. Usually we call the first point s1, y1. Call the second point s2, y2. Then we plug in the points. y2 minus y1. 2 minus 2. y2 minus y1 is 2 minus 2. Over x2 minus s1. That's 4 minus negative 3. Then on the top, 2 minus 2 is 0. On the bottom, 4 minus negative 3, we need to convert subtraction to addition. 4 plus positive 3. When I change subtraction to addition, I change the sign of the second number. Then we have 0 over 4 plus positive 3 is 7. 0 divided by 7 is 0. 0 divided by 7 is 0. So the slope of this line is 0. Slope of this line is 0. Next. Graph the line. Passing through points 1, -2 and 1, 3, and find the slope of the line. Graph the line passing through points 1, -2 and 1, 3, and then find the slope of the line. Let's first of all draw the coordinate plane first. In the coordinate plane, horizontal line is called the x-axis. Vertical line is called the y-axis. Number in the middle is 0. Numbers to the left are positive numbers. So numbers to the right are positive numbers. Numbers to the right side are positive numbers. Numbers to the right are positive numbers. Numbers to the left are negative numbers. Numbers above 0 are positive numbers. Numbers below 0 are negative numbers. -1, -2, -3. Then plot the points. First point 1, -2. X coordinate is 1. Y coordinate is -2. X coordinate is 1. Y coordinate is -2. That's the first point. 1, -2. X coordinate is 1. Y coordinate is -2. That's the first point. 1, -2. Second point 1, 3. X coordinate is 1. Y coordinate is 3. X coordinate is 1. Y coordinate is 3. So the point is here. X coordinate is 1. Y coordinate is 3. This point is 1, 3. Then by connecting 2 points, we can make a line. Connect these 2 points together, we can make a straight line. This is the graph of the line. This is the graph of the line. Then slope. Then we try to find the slope. Formula for slope is y2 minus y1 over x2 minus s1. We call the first point x1, y1. We call the second point x2, y2. So y2 minus y1 is 3 minus -2 over x2 minus s1, 1 minus 1. I can first of all convert subtraction to addition. So it becomes 3 plus positive 2. When I convert subtraction to addition, change the sign of the second number. -2 become positive 2. On the bottom, 1 minus 1 is 0. On the top, 3 plus 2 is 5. 5 divided by 0. We know for fractions, the denominator cannot be 0. Any number divided by 0 is undefined. So this is undefined. Undefined. Any number divided by 0 is undefined. For any fraction, if the denominator is 0, it's undefined. So that's a special case. We say the slope is undefined. When denominator is 0, a fraction is undefined. If the slope is undefined, we say the slope is undefined. If the denominator is 0, we say the slope is undefined. So that's what we did last class. Next, we try to find out the relationship between the slope and the graph. Next, let's try to find out the relationship between the slope and the graph. Let's observe this old example first. Look at the first problem. The first problem, slope is positive. In the third problem, slope is also positive. Observe the graph. We can see that when the slope is positive, the line slants upward from left to right. The line slants upward from left to right. When the slope is positive, the line slants upward from left to right. And for example 2 and example 4, we can see that when the slope is negative, the line slants downward from left to right. The line slants downward from left to right. So, first relationship, we can say if slope is positive, then the line slants upward from left to right. If slope is negative, the line slants downward. From left to right. If the slope is positive, greater than 0 means positive. If the slope is positive, the line slants upward from left to right. That means it's increasing from left to right. If the slope is negative, the line slants downward from left to right. That means the line is decreasing from left to right. As in example 1 and 3, you can see that when the slope is positive, the line slants upward from left to right. Slant upward means increasing, the line is increasing from left to right. When the slope is positive, the line is increasing from left to right. From left to right, the line is increasing. If the slope is negative, the line slants downward from left to right, which means the line is decreasing from left to right. If the slope is negative, the line slants downward from left to right. That means the line is decreasing from left to right. Next, let's observe example 5 and 6. Observe 5 and 6. When the slope is 0, we see that the line is horizontal. When the slope is 0, the line is horizontal. And when the slope is undefined, the line is vertical. So, next. If the slope is 0, then the line is horizontal. And if the slope is undefined, then the line is vertical. Let's look at example 5 and 6. We can see that When slope is zero, the line is horizontal. When slope is undefined, the line is vertical. So that's the relationship between slope and line. When the slope is positive, the line slants upward from left to right. It looks like this. The line slants upward from left to right. If slope is negative, the line slants downward from left to right. It looks like this. From left to right, the line slants downward. If slope is zero, the line is horizontal. If slope is zero, the line is horizontal. If slope is undefined, the line is vertical. So that's the relationship between slope and the lines. Next, we will study how to sketch graphs using slopes. Look at this example. Look at the following example. Graph a line passing through point 1, 2 with slope 3/2. Graph a line passing through the point 1, 2 with slope 3/2. Let's draw the coordinate plane first. Number in the middle is 0. Numbers to the left are 1, 2, 3, 4, 5, 6, 7. Number to the left are negative. Numbers above 0 are positive numbers. 1, 2, 3, 4, 5, 6. Numbers below 0 are negative. -1, -2. First of all, let's plot the point 1, 2. Let's plot the point 1, 2 first. 1, 2 means x is 1, y is 2. So point 1, 2 is here. That's point 1, 2, where x is 1, y is 2. Now, slope. We try to sketch the graph, use slope. Slope is 3/2. Remember, slope represents change of y over change of x, which also means rise over run. Slope means rise over run. So in this example, rise is 3, run is 2. Rise is 3 means we go up by 3 units. 1, 2, 3. Go up by 3 units. Run is 2 means we go 2 units to the right. Go up by 3 units. Go up by 3 units. Run is 2 means we go 2 units to the right. 1, 2. So that's the second point here. Rise is 3, go up by 3 units. Run is 2. Means we moved 2 units to the right. So rise is 3, run is 2. The new point here is 3, 5. Rise is 3, 2 plus 3 is 5. Run is 2, 1 plus 2 is 3. Rise over run. 2, rise is 3, 2 plus 3 is 5. Run is 2, 1 plus 2 is 3. That's your new point. Go up by 3 units and go 2 units to the right. Then connect 2 points, you can make a line. Connect 2 points, you can make a line here. That's how we sketch graph using slope. Next, let me show you a different example. Number 2. Graph a line passing through a point -3, 1 with slope -2, 2/3. Graph a line passing through -3, 1 with slope -2/3. So first of all, let's draw a coordinate plane. 0 in the middle. Number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. We first of all label the point, plot the point. We first of all plot the point -3, 1, which means x coordinate is -3, y coordinate is 1. X coordinate is -3, y coordinate is 1. Plot the point, we have -3, -1. Sorry, -3, +1, that's the point. X is -3, y is +1. Slope is -2/3. Slope is -2/3. Now if the slope is negative, we attach negative sign to the numerator. We're allowed to attach the slope to either negative sign to either the top or the bottom. To make it easier, attach negative sign to the numerator. When the slope is negative, to make it easier, attach negative sign to the numerator. So I write it as -2/3. To make it easier, attach negative sign to the numerator. So the rise is -2. Long is 3. If the rise is -2, means we go down by 2 units. Long is 3. Means we go 3 units to the right. Long is 3. We go 3 units to the right. 1, 2, 3. If the long is 3, we go 3 units to the right. That's the second point. This point, observe the coordinate. Rise is -2, means I go down by 2. Number 1 go down by 2, become -1. So the y coordinate is -1. From number 1, if I go down by 2 units, I get -1. And the long, I go 3 units to the right side. From the long is 3, I go 3 units to the right side. 1, 2, 3. It was -3. If I go 3 units to the right, -2, -1, 0, it becomes 0. If I go 3 units to the right, -3 becomes 0. So rise is -2, go down by 2 units. Number 1, start from number 1, if I go down by 2 units, it becomes -1. Long is 3, so I move 3 units to the right side. Start from -3. If I move 3 units to the right side, I get -2, -1, 0. So that's my new coordinate point. Then by connecting 2 points, we can make a line. Connect 2 points together, I can make a line. If I connect 2 points together, I can make a line. That's the graph of the line. Next. Graph a line. Passing through the point 2, -3 with slope +2. Graph a line passing through the point 2, -3 with slope +2. How do we graph this line? So first of all, we draw the coordinate plane first. Draw the coordinate plane first. Number in the middle is 0. The numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's plot the point 2, negative 3. Let's plot the point 2, negative 3. Let's plot the point 2, negative 3. That means when x coordinate is 2, y coordinate is negative 3. When x coordinate is 2, y coordinate is negative 3. So that's the point 2, negative 3. Slope of 2. What does it mean, slope of 2? When the slope is 2, I can put it over 1. If the slope is a whole number, put the whole number over 1. Then we can tell the rise is 2. The long is 1. If the slope is a whole number, put it over 1. Then we can tell the rise is 2, the long is 1. So rise is 2, go up by 2 units. Go up by 2 units. When the rise is 2, go up by 2 units. Long is 1, we go 1 unit to the right side. Rise over long. When rise is 2, we go up by 2 units. When the long is 1, go 1 unit to the right. The new point here. Rise is 2. From negative 3, if you go up by 2 units, it becomes negative 1. So the y coordinate is negative 1. For the s coordinate was 2. If I go 1 unit to the right, it becomes 3. That's your new point. Rise is 2. Rise it was negative 3. If you go up by 2, it becomes negative 1. The long was 2. If you go 1 unit to the right, it becomes 3. So rise is 2. Negative 3 plus 2 is negative 1. From negative 3, if you go up by 2 units, you get negative 1. Rise was 2. If you go 1 unit to the right, it becomes 3. Then connect 2 points, we can make a line. Connect 2 points, connect these 2 points, we can make a line. Connect 2 points, we can make a line. Next, graph a line. Passing through the point negative 1, 4 with slope 0. Graph a line passing through negative 1, 4, passing through 0 with slope 0. Graph a line passing through negative 1, 4 with slope 0. We draw the coordinate plane first. In the coordinate plane, label the x and y axis. Draw coordinate plane first. We have 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Plot the first point, negative 1, 4. Plot the first point first, negative 1, 4. When s is negative 1, y is 4. So we are here. When s is negative 1, y is 4. We are here. That's the point, negative 1, 4. When s is negative 1, y is 4. That's the point. Next, we try to graph a line using the slope. When the slope is 0, that means the line is horizontal. That's the property, that's the relationship between slope and line. When the slope is 0, the line is always horizontal. When slope is 0, the line is horizontal. So we draw a horizontal line passing through the point. We draw a horizontal line passing through the point. And this horizontal line goes through, passing through 4 in the y-axis. You can see that this horizontal line, it goes through 4 in the y-axis. So this point here, a second point on the graph will be 0, 4. For number 4 in the y-axis, x coordinate is 0, y coordinate is 4. So that's the second point on the line. To graph a horizontal line passing through -1, 4, we draw a line horizontally. And this horizontal line will cross 4 because 4 is the y coordinate. It will cross 4 in the y-axis. And for this point in the y-axis, x coordinate is always 0. For points in the y-axis, the x coordinate is always 0. That's the line. That's the line passing through -1, 4 with slope of 0. Next, graph a line passing through the point 5, 2 with undefined slope. Graph a line passing through point 5, 2 with undefined slope. So let's plot the point 5, 2 first. Draw coordinate plane, plot the point 5, 2 first. Number in the middle is 0. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Plot the point 5, 2 first. 5, 2 means when x coordinate is 5, y coordinate is 2. When x coordinate is 5, y coordinate is 2. That's the point 5, 2. Plot the point first. Then we try to sketch a line by using the slope. Undefined slope. If the slope is undefined, that means the line is vertical. If the slope is undefined, that means the line is vertical. So we draw a vertical line passing through 5, 2. And we can see that if I draw a vertical line passing through 5, 2, it actually goes through 5 in the x-axis. If I draw a vertical line passing through 5, 2, actually it goes through number 5 in the x-axis. So a second point on the line will be 5, 0. A second point on the line will be 5, 0. A second point on the line will be 5, 0. X coordinate is 5. At this point, x coordinate is 5. Y coordinate is 0. So when we graph a line, we need 2 points. A second point here is 5, 0. Well, x coordinate is 5. Y coordinate is 0. When we graph a line, we need 2 points. So when we draw a vertical line passing through 5, 2, we can see that it goes through 5 in the x-axis. And for this point, x coordinate is 5, y coordinate is 0. That's how I find the second point. When we draw a vertical line passing through 5, 2, it goes through 5 in the x-axis. And for this point, x-coordinate is 5, y-coordinate is 0. And same thing in the previous example, you can see that. When we draw a vertical line passing through -1, 4, it goes through 4 in the y-axis. So for this point, the coordinate is 0, 4. X-coordinate is 0, y-coordinate is 4. When we draw a line, we need 2 points. That's how I find the second point. If it's not given, that's how I find the second point. Next, let's do more practice. Graph the following lines in the same coordinate plane. Graph the following lines in the same coordinate plane. Graph the following lines in the same coordinate plane. Line 1. Line 1 is a line passing through the point -1, -2 with slope 3/4. Line 2 is a line passing through the point -3, 1 with slope 3, 4. Let's try to graph these two lines in the same coordinate plane. So let's draw the coordinate plane first. The 0 in the middle, numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's graph the first line first. Graph the first line. Let's plot the point 1, 2. Let's plot the point 1, -2 first. 1, -2 means when x coordinate is 1, y coordinate is -2. When x coordinate is -1, y coordinate is -2. That's a point here. When the x coordinate is -1, y coordinate is -2. That's a point here. Slope is 3/4. That means rise over long is 3/4. That means when the rise is 3, long is 4. So go up by 3 units. 1, 2, 3. When the rise is 3, long is 4. Go 4 units to the right. 1, 2, 3, 4. We are here. Rise is 3, long is 4. 3/4 means the rise is 3, the long is 4. Three over 4 means the rise is 3, the long is 4. Go up by 3 units. 1, 2, 3. Then go 4 units to the right. 1, 2, 3, 4. Connect 2 points, we can make a line. And by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. That's line 1. And the second line, a line passing through -3, 1 with slope 3/4. -3, 1. Let's plot the point first. That means where x is -3, y is 1. When x is -3, y is 1. When x is -3, y is 1. That's the second point. That's -3, 1. When x is -3, y is 1. Slope is 3/4, means when the right is 3, wrong is 4. That means when the right is 3, wrong is 4. 1, 2, 3, go up by 3 units. When the right is 3, go up by 3 units. 1, 2, 3. Wrong is 4, means we go 4 units on the right side. 1, 2, 3, 4. We are here. 1, 2, 3, 4. So start from -3, 1. Right is 3, wrong is 4. When the right is 3, 1, 2, 3, 4, it becomes 4. Wrong is 4. Start from -3, wrong is 4. 1, 2, 3, 4. It becomes 1. So the new point is 1, 4. Connecting 2 points, we can make a line. That's my line 2. That's my line 1. In my line 1, the first point is -1, -2. Right is 3, wrong is 4. I go up by 3 units. If I go up by 3 units, start from -2. If I go up by 3 units, 1, 2, 3, become +1. Wrong is 4, means I go 4 units on the right side. I start from -1, go 4 units on the right side. 1, 2, 3, 4. The x coordinate is 3. And connect 2 points, we can make a line. That's my line 1, that's my line 2. If you compare these two lines, it looks like they are parallel, right? It looks like they have same slope, and these two lines are parallel. It looks like when the slope is the same, the lines are parallel. Next example. Graph the following lines in the same coordinate plane. Graph the following lines in the same coordinate plane. First line. Line 1. Line 1 is a line. Passing through the point -2, 1. With slope -2/3. Line 2 is a line. Passing through the point 3, 2. With slope 3/2. So let's draw the coordinate plane first. The coordinate plane 0 in the middle, and the numbers from the right are positive. Numbers from the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's graph line 1 first. So I first of all plot a point negative 2, comma 1. That means when x is negative 2, y is 1. Plot a point negative 2, comma 1 first. Next, we try to use the slope to graph the line. So for first line, slope is negative 2 over 3. For the first line, slope is negative 2 over 3. We attach negative sign to the numerator. When the slope is negative, attach negative sign to the numerator. So that's my right. 3 is not wrong. Right is negative 2, wrong is 3. Right is negative 2 means I go down by 2 units. 1, 2, go down by 2 units. Wrong is 3, means I go 3 units on the right. 1, 2, 3. So my terminal point here is 1, comma negative 1. My terminal point is 1, comma negative 1. Start from 1, if I go down by 2 units, it's negative 1. And start from negative 2, if I go 3 units to the right, 1, 2, 3, it becomes positive 1. So that's my new point. By connecting 2 points, we can make a line. By connecting 2 points, I can make a line. That's my line 1. Next, the second line, line 2. Point is 3, comma 2. X is 3, y is 2. That's my point. 3, comma 2. That's the point, 3, comma 2. When x coordinate is 3, y coordinate is 2. Then slope is 3 over 2. That means my right is 3, wrong is 2. Right is 3, wrong is 2. Right is 3 means I go up by 3 units. 1, 2, 3. Wrong is 2 means I go 2 units on the right side. So go up by 3 units. Go 2 units on the right side. 1, 2, 3, and 2 units on the right side. What's the coordinate of the new point? When I go up, I start from 2. Start from 2, go up by 3 units. My y coordinate is 5. Now I go 2 units on the right side. My x coordinate is 3. If I go 2 units on the right, it becomes 5. So that's the coordinate of the new point. Then by connecting 2 points, I can make a line. By connecting 2 points, I can make a line. By connecting 2 points, I can make a line. That's my line 2. If you draw properly, we can see that these 2 lines, it looks like they are perpendicular. These 2 lines looks like they are perpendicular. Observe their slope. How is the slope here? It looks like the slope, one is positive, one is negative. First one is negative, second one is positive. And they look exactly the same, but they are the reciprocal. The numerator is the denominator. The denominator is the numerator. That's called reciprocal. So it looks like The lines are perpendicular and the slope has different sign, and they are reciprocal of each other. They are reciprocal of each other. The lines are perpendicular and the slopes are reciprocal of each other. Based on this example and the previous example, what conclusion can we make? So keep in mind that the first example tells you if two lines are parallel, then their slopes are the same. They must have the same slope. If two lines are parallel, then their slopes are the same. That comes from the previous example. If two lines are parallel, then their slopes are exactly the same. If two lines are parallel, their slopes are exactly the same. Next. If two lines are perpendicular, then their slopes are negative reciprocal of each other. Their slopes are negative reciprocal of each other. If two lines are perpendicular, their slopes are negative reciprocal of each other. Negative reciprocal means they have different positive negative sign, and the fraction has switched denominator and numerator. The fraction has opposite denominator and numerator. They have opposite sign, and the fraction has opposite denominator and numerator. That's called negative reciprocal. They have opposite sign, and the fraction has opposite denominator and numerator. Next, let's do a little example about negative reciprocal. Find the negative reciprocal for each of the following numbers. Find the negative reciprocal for each of the following numbers. So, for example, how do we find negative reciprocal for 3 over 4, for example? How do we find the negative reciprocal for 3 over 4? So, to find negative reciprocal, change the sign, flip over. So 3 over 4, if I find negative reciprocal, I first of all make it negative. Then I flip the top and the bottom over, it becomes negative 4 over 3. So that's the negative reciprocal of 3 over 4. Next, how do we find negative reciprocal for negative 3 over 5? How do we find negative reciprocal for negative 3 over 5? So, when we try to find negative reciprocal, we change the sign. If it's negative, we make it positive. Then flip it over. 3 over 5. If I flip over, become 5 over 3. That's the negative reciprocal of negative 3 over 5. And for the final answer, if a number is positive, we don't write positive sign. So negative reciprocal is 5 over 3. Next, how do we find negative reciprocal for negative 4 over 1? So first of all, if a number is negative, we make it positive. flip over, interchange the denominator and numerator, and make it 4 over 1. Then if the number is positive, I don't write positive sign. 4 over 1 is actually 4. 4 divided by 1 is actually 4. So number 4 is the negative reciprocal of negative 4 over 1. Next, 1 over 2. How do we find the negative reciprocal for 1 over 2? So first step, change the sign. If it's positive, we make it negative. Then flip over. 1 over 2, if I flip over, become 2 over 1. Then if the number is negative, I keep the negative sign. But 2 over 1 can be rewritten as 2, because 2 divided by 1 is 2. 2 divided by 1 is 2. So negative 2 is the negative reciprocal of 1/2. Next, how do we find negative reciprocal for negative 3? So first of all, for whole number, we first of all put it over 1. We first of all put the whole number over 1 first. First of all, put the whole number over 1. Then when we are finding negative reciprocal, change the sign and flip the fraction over. If I change the sign, negative 3 over 1 become positive 3 over 1. Then flip the fraction over. Interchange the top and the bottom, become 1 over 3. For your final answer, if the number is positive, we don't write positive sign. So 1/3 is the negative reciprocal of negative 3. Next, how about number 5? How do we find the negative reciprocal for number 5? So first of all, we rewrite number 5 as 5 over 1. When we see a whole number, put it over 1 first. Then when we are finding negative reciprocal, we change the sign and flip the fraction over. Positive 1 over 5. So positive 5 over 1. If we change the sign, it becomes negative. Then if I flip the fraction over, it becomes 1 over 5. So negative 1 over 5. Negative 1 over 5 is the negative reciprocal of positive 5. Next, we will study equation of lines. So first of all, keep one thing in mind. Note, in the coordinate plane, every linear equation represents a straight line. In a coordinate plane, every linear equation represents a straight line, and every straight line can be represented by an equation. So keep this basic idea in mind. In a coordinate plane, every linear equation represents a straight line, and every straight line can be represented by a linear equation. Keep this idea in mind. And also, a line contains infinitely many points. In general, a line in a coordinate plane contains infinitely many points. But in order to graph a line, we only need 2 points. But in order to graph a line, to graph a straight line, in order to graph a straight line, we only need 2 points. In general, a line in the coordinate plane contains infinitely many points, but in order to graph a line, we only need 2 points. That means if I can find 2 points on a line, I can graph the line. If I can find 2 points on the line, I can graph the line. Next, let's do some example about equation of lines. Let 2x plus 3y equal to 12 represent the equation of a line. Let 2x plus 3y equal to 12 represent equation of a line. For each of the following points, determine whether it's on the line. So let 2x plus 3y equal 12 represent equation of a line. For each of the following points, determine whether it's on the line. So we have 6 points here. First point, point A is 3, 2. Point B is 1, 2. Point C is 0, 4. Point D is -1, 5. Point E is 6, 0. Point F is 9, -2. We try to determine whether these points locate on the line. So let's check first point. For point A, 3 represent x, 2 represent y. So I plug in x and y to check the equation. If these 2 points satisfy the equation, if these 2 numbers satisfy the equation, then we say point A is on the line. If these 2 numbers doesn't satisfy the equation, then we say point A is not on the line. Let's check. If I plug in 3 for x, I have 2 times 3 plus 3 times 2. I substitute 3 for x. I substitute 2 for y. I want to check whether they equal to 12. If this equation equal to 12, then we say A locate on the line. Otherwise, A is not on the line. Let's check. 2 times 3 is 6. 6 plus 6 equal to 12. That's true. 6 plus 6 equal to 12. That's true. So we say A is on the line. So A is on the line. Let's check for point B. Point B, I substitute 1 for x, substitute 2 for y. I have 2 times 1 plus 3 times 2. I substitute 1 for x. I substitute 2 for y. I want to check whether it equal to 12. If this equation equal to 12, then point B satisfies the equation. Then we say point B is on the line. Otherwise, we say B is not on the line. Let's multiply. 2 times 1 is 2. 3 times 2 is 6. 2 plus 6 is 8, which is not 12. So point B doesn't satisfy the equation. So say B is not on the line. So point B is not on the line. Next, let's test for point C. Point C is we have 0, 4. 0 represents x, 4 represents y. So I can substitute 0 for x, substitute 4 for y. I have 2 times 0 plus 3 times 4. I want to check if that equal to 12. If that equal to 12, that means point C satisfies the equation and C located on the line. If C doesn't satisfy the equation, then C is not on the line. Let's multiply. 2 times 0 is 0. 3 times 4 is 12. 3 plus 0 plus 12 equal to 12. That's true. So point C is on the line. And let's check point D. Point D we have -1, 5. -1 represents x, 5 represents y. So I substitute -1 for x, substitute 5 for y. If point D satisfies the equation, then point D is on the line. Let's check. I plug in -1 for x, plug in 5 for y. I get 2 times -1 plus 3 times 5. I want to check if that equal to 12. If that equal to 12, then point D satisfies the equation and it's on the line. Otherwise, D is not on the line. Let's multiply. 2 times -1 is -2. 3 times 5 is 15. Is it 12? -2 plus 15, is it 12? Let's try to add. -2 plus 15. When we are adding two numbers with different sign, we keep the sign from the number that has larger magnitude. Here 15 has larger magnitude, so I keep positive sign. 15 and subtract the magnitude. 15 minus 2 is 13. And we can see that 13 doesn't equal to 12. So point D is not on the line. So D doesn't satisfy the equation. D is not on the line. So point D is not on the line. Let's check point E. Let's check point E. E is the point 6, 0. Let's check whether point E is on the line. So for point E, I plug in 6 for x, plug in 0 for y. I have 2 times 6 plus 3 times 0. We want to check if that equal to 12. If this equation equal to 12, then we say point E satisfies the equation and is located on the line. Otherwise, we say E is not on the line. Let's check. 2 times 6 is 12. 3 times 0 is 0. 12 plus 0, that is 12. So E, point E satisfies the equation. So we say point E is on the line. So point E is on the line. Next, let's check point F. Point F, 9, -2. Number 9 represents x, -2 represents y. We try to plug in 9 and -2 to see if point F satisfies the equation. Let's check. I plug in 9 for x, -2 for y. 2 times 9 plus 3 times -2. I want to check if that equals to 12. 2 times 9 is 18. 2 times 9 is 18. 3 times -2 is -6. We want to check if that's 12. 18 plus -6. When we are adding two numbers with opposite sign, we keep the sign from the number that has larger magnitude. Here 18 has larger magnitude, so I keep positive sign. Then subtract the magnitude. 18 minus 6 is 12. 12 equal to 12. 12 equal to 12. So point F satisfies the equation, and point F located on the line. So here point F is on the line. Next example. Let 4x plus 5y equal to 20 represents the equation of a line. For each of the following points on the line, find the missing components. For each of the following points on the line, find the missing components. So point A is the point -10, y coordinate is missing. Point B is the point -5, y coordinate is missing. Point C is the point 0, the y coordinate is missing. Point D is the point something, -4, s coordinate is missing. Point E is the point something, -8, s coordinate is missing. Point F is the point something, -12, s coordinate is missing. So we try to find the missing component for each point. And remember, if a point is on the line, a point must satisfy the equation. So for point A, I plug in -10 for x, solve for y. That's what I put here. For point A, I plug in -10 for x, solve for y, put it here. That's how I find the missing component for point A. So for point A, I substitute -10 for x, then solve for y. I have 4 times -10 plus 5 times y equal to 20. I substitute -10 for x, then solve for y. 4 times -10 is -40 plus 5y equal to 20. If I want to get y by itself, I need to eliminate 40 first, then eliminate 5. I get y by itself. So I add 40 to both sides first. On the left side, positive 40 and -40 get cancelled. We have 5y equal to 60. Then in order to get y by itself, I divide both sides by 5. On the left side, number 5 on the top and the bottom get cancelled. We get y by itself. On the right side, 60 divided by 5 is 12. So we find out the missing component is y is 12. That's how I find the missing component here. Next, for point B. For point B, I substitute negative 5 for x. The first component represents x. I substitute negative 5 for x. I solve for y. I have 4 times negative 5 plus 5y equal to 20. I substitute negative 5 for x, then solve the equation for y. 4 times negative 5 is negative 20 plus 5y equal to 20. In order to get y by itself, I need to eliminate negative 20 first, then eliminate 5. So all I can do is I can add 20 to both sides. Positive 20 and negative 20 can cancel. We have 5y left on the left side. On the right side, 20 plus 20 is 40. In order to get y by itself, I divide both sides by 5. Number 5 and number 5 can cancel. We get y by itself on the left side. On the right side, 40 divided by 5 is 8. So I get y equal to a. A is the missing component. I put it here. Then for point C, do the same thing. I plug in 0, substitute 0 for x, then solve the equation for y. I have 4 times 0 plus 5y equal to 20. 4 times 0 is 0. 0 plus 5y is 5y. Then, in order to get y by itself, I divide both sides by 5. Number 5 on the left side and right side can cancel. I get y by itself. 20 divided by 5 is 4. So that means when x is 0, y must be 4. When x is 0, y must be 4. Next, for point D, x component is missing. For point D, x component is missing. Y component is negative 4. So I substitute negative 4 for y, and I'm solving for x. I have 4x plus 5 times negative 4 equal to 20. Multiply the numbers first. Positive 5 times negative 4 is negative 20. I leave 4x the same, equal to 20. Positive 5 times negative 4 is negative 20. Leave the rest the same. Then, in order to get x by itself, I need to eliminate 20 first, negative 20 first. Then eliminate 4, I get x by itself. So I add 20 to both sides. On the left side, positive 20 and negative 20 can cancel. We get 4x by itself. On the right side, 20 plus 20 is 40. In order to get x by itself, I divide both sides by 4. Then on the left side, positive 4 and negative 4 can cancel. We get x by itself. On the right side, 40 divided by 4 is 10. So x is 10. That means the missing component is 10. Then for point E, do the same thing. For point E, do the same thing. For point E, x component is missing. Y component is negative a. So I substitute negative a for y, then solve for x. I substitute negative a for y, then solve for x. I substitute negative a for y, solve for x. So I have 4x plus 5 times negative a. I substitute negative a for y, solve for x, equal to 20. Multiply the numbers first. Positive 5 times negative 8 is negative 40 equal to 20. In order to get x by itself, I need to eliminate 40 first, then eliminate 4, I get x by itself. So I add 40 to both sides. On the left side, positive 40 and negative 40 can cancel, we get 4x by itself. On the right side, 20 plus 40 is 60. Then, in order to get x by itself, I divide both sides by 4. Then on the left side, positive 4 and negative 4 can cancel, we get x by itself. On the right side, 60 divided by 4 is 15. So x is 15. That means the missing component is 15. Put it here. Then for point F, S component is missing. S component is missing. We know Y component is negative 12. So I substitute negative 12 for Y. Then solve an equation for x. I have 4x plus 5 times negative 12 equal to 20. I substitute negative 12 for y. Solve an equation for x. Multiply numbers first. Positive 5 times negative 12. Positive 5 times negative 12 is negative 60. That equal to 20. In order to get x by itself, I need to eliminate 60 first, then eliminate 4. Add 60 to both sides. Cancel 60, I have 4x by itself. On the other side, 20 plus 60 is 80. In order to get x by itself, we divide both sides by 4. Then on the left side, positive 4 and negative 4 can cancel, we get x by itself. On the right side, 80 divided by 4 is 20. So I get x is 20. That's the missing x component. Put it here. Another example. Let 2x equal to 3y. Represent the equation of a line. Assume the following table represents points on the line. Complete the tables. Let 2x equal to 3y represents equation of a line. Assume the following table represents points on the line. Complete the table. The table looks like this. First column, x, y. Second column, x is negative 9, y is missing. Third column, x is negative 6, y is missing. So second column, x is negative 6, y is missing. Next column, x is negative 3, y is missing. Next column, x is 0, y is missing. Next column, y is 2, s is missing. Next column, y is 4, s is missing. Next column, y is 6, s is missing. So complete the table, find the missing components. So look at this way. The table represents points on the equation, points on the line. That means each point, each sy, each pair of s and y satisfies this equation. If the table represents points on the line, then each pair of x and y represent a point, and it satisfies this equation. So for the first point, For the first point, x equal to -9. For the first point, x equal to -9. We substitute -9 for x and solve for y. We have 2 times -9 equal to 3y. 2 times -9 is -18. In order to get y by itself, I divide both sides by 3. On the right side, positive 3, -3 can cancel, we get y by itself. On the left side, -18 divided by 3 is -6. So when x is -9, y is -6. Put it here. That's the first point. When x is -9, y is -6. Second point, when x is -6, we substitute -6 to find y. For the second point, second column, I substitute -6 for x and solve for y. I have 2 times -6 equal to 3y. 2 times -6 is -12 equal to 3y. In order to get y by itself, I divide both sides by 3. So I get y equal to -4. -12 divided by 3 is -4. So put it here. That's the missing component. Put it here. Third column, x is -3. We are looking for the missing y component. X equal to -3. I substitute -3 for x. I'm solving for y. I have 2 times -3 equal to 3y. 2 times -3 is -6. In order to get y by itself, I divide both sides by 3. So I get y equal to -2. Next column, x is 0. Sorry, well, x is -3, y is -2. Next column, x is 0. We are looking for y. When x is 0, we substitute 0 for x, then solve for y. Substitute 0 for x. I have 2 times 0 equal to 3y. Substitute 0 for x, solve for y. 2 times 0 is 0, equal to 3y. In order to get y by itself, I divide both sides by 3. Positive 3 on the top and the bottom can cancel. I get y by itself on the right side. On the left side, 0 divided by 3 is 0. So when x is 0, y is also 0. Next column, x is missing, y is 2. Next column, x is missing, but y is 2. I substitute 2 for y and solve for x. Next column, y is 2. I substitute 2 for y and solve for x. I have 2x equal to 3 times 2. I substitute 2 for y, solve for x. 3 times 2 is 6. I leave 2x the same. 3 times 2 is 6. In order to get x by itself, I divide both sides by 2. So on the left side, x on the top, 2 on the top and the bottom get cancelled. We get x by itself. 6 divided by 2 is 3. So well, y is 2, x is 3. Next column, y is 4. When y is 4, we try to find the missing x component. I substitute 4 for y, solve for x. 2x equal to 3 times 4. And we know that 3 times 4 is 12. Leave 2x the same. In order to get x by itself, I divide both sides by 2. Then number 2 on the left side and right side can cancel. We get x by itself. On the right side, 12 divided by 2 is 6. So when y is 4, x is 6. The last column, y is 6, x is missing. So y is 6, but x is missing. We have 2x equal to 3 times y, plugging 6 for y. X equal to 3 times 6. 3 times 6 is 18. Leave 2x the same. In order to get s by itself, we divide both sides by 2. So number 2 on the top and the bottom get cancelled. We get s by itself. 18 divided by 2 is 9. So when y is 6, the missing s component is 9. Next, we'll study the graph of lines represented by equations, represented by linear equations. As we know that in a coordinate plane, every line can be represented by an equation, and every equation represents a line in a coordinate plane. Next, we'll study how to graph lines based on an equation. Next, we'll study how to graph lines based on equations. Graph the line based on graph the line represented by the given equations. Graph the line based on graph the line represented by the given equations. Suppose I give you a line, give an equation 2x plus y equal to 3. Suppose we have a line 2x plus y equal to 3. How do we graph the line that represented by this equation? We know every equation represents a line. Every equation represents a line. How do we graph the line that represented by this equation? Remember, to graph a line, we need to find 2 points. If I can connect 2 points, I can make a straight line. To graph a line, we need to find 2 points. If I can find 2 points, by connecting 2 points, I can make a line. So let's try to find 2 points first. In general, when we try to find 2 points, we try to find the x and y intercept first. If you want to find 2 points, we try to find the x and y intercepts. We try to find x and y intercepts. So let's find the x intercept first. For x intercept, we set y equal to 0. For x intercept, set y equal to 0. Remember, when we have a line, x-intercept located in the x-axis, in which the y-coordinate is always 0. For y-intercept, it located in the y-axis. The s-coordinate is always 0. For y-intercept, its s-coordinate is always 0. For s-intercept, its y-coordinate is always 0. So to find s-intercept, you set y equal to 0. To find y-intercept, you set s equal to 0. To find s-intercept, you set y equal to 0. To find y-intercept, you set s equal to 0. To find s-intercept, you set y equal to 0. To find y-intercept, you set s equal to 0. So for s-intercept, I set y equal to 0. I plug in 0 for y, solve for x. So I plug in 0 for y. I have 2x plus y, y is 0, equal to 3. I substitute 0 for y, then solve for x. 2x plus 0 is the same as 2x. Then we get 2x equal to 3. I can divide both sides by 2. S equal to 3 over 2. So s-intercept is 3 over 2. How big is 3 over 2? Take 3 divided by 2. 2 goes into 3 one time. 1 times 2 is 2. Remainder is 1. So 3 half can be rewritten as 1.5. 3/2 can be rewritten as 1.5. For y-intercept, if say x equals 0, plug in 0 for x, we have 2 times 0 plus y equal to 3. 2 times 0 is 0. 0 plus y equal to 3. 0 plus y is the same as y, so we have y equal to 3. We know x-intercept is 3 over 2. Y-intercept is 3. Then we sketch the graph. X-intercept is 3 over 2. Y-intercept is 3. Let's draw the coordinate plane first. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. X-intercept is 1.5. X-intercept is 3 over 2. 3 over 2 is 1.5. 1.5 is somewhere between 1 and 2. That's the x-intercept. Y-intercept is 3. So x-intercept here is 1.5, 0. X-intercept is 3 over 2, 0. X is 3 over 2, y is 0. That's the x-intercept. Y-intercept is 0, 3. X coordinate is 0, y coordinate is 3. By connecting 2 points, we can make a line. So this equation represents this line. That's the line represented by this equation. Every equation represents a line. If we know an equation, we can always graph the line on the xy plane. Next, x minus 2y equal to 4. We try to graph the line that is represented by this equation. So to find equation of a line, we need to know 2 points. Once I know 2 points, by connecting 2 points, we can make a line. Usually, we prefer to use the x-intercept and the y-intercept. For x-intercept, set y equal to 0. And for y-intercept, set x equal to 0. For x-intercept, you set y equal to 0. To find y-intercept, you set x equal to 0. So let's find x-intercept first. I plug in 0 for y. I have x minus 2 times 0 equal to 4. I plug in 0 for y, solve for x. 2 times 0 is 0. Then x minus 0 is x, equal to 4. So x-intercept is 4. For y-intercept, I set x equal to 0. Plug in 0 for x. I have 0 minus 2y equal to 4. 0 minus 2y is negative 2y. 0 minus 2y is negative 2y. In order to get y by itself, I divide both sides by negative 2. On the left side, negative 2 on the top and the bottom get cancelled. We get y by itself. On the right side, positive 4 divided by negative 2 is negative 2. Positive number divided by negative number is negative. 4 divided by 2 is 2. So x-intercept is 4. Y-intercept is negative 2. Now next, let's sketch the graph. Number in the middle is 0. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. X-intercept is 4, so we find number 4 in the x-axis. Y-intercept is -2, we find -2 in the y-axis. This point, x-intercept is 4. For the x-intercept, the y-coordinate is always 0. So for this point, we label as 0, 4. So 4, 0. This point we labeled as 4, 0. For the x-intercept, y-coordinate is always 0. For x-intercept, y-coordinate is always 0. 4, 0. This point is 4, 0. X-coordinate is 4. Y-coordinate is 0. And for this point, for the y-intercept, x-coordinate is always 0. For this y-intercept here, the x-coordinate is always 0. So this point can be written as 0, -2. This point can be written as 0, -2. Then by connecting 2 points, we can make equation of lines. By connecting 2 points, we can make equation of lines. And this line is represented by that equation. This is a line represented by the given equation. That's what we want. This is a line represented by the given equation. That's how we find a line based on the given equation. Next, -3 minus 2x equal to 3y. Let's graph the line that represented by this equation. To graph the line, we need to find 2 points. Usually we try to find the x and the y-intercepts. For the x-intercept, we set y equal to 0. For the y-intercept, we set s equal to 0. For the s-intercept, we set y equal to 0. For the y-intercept, we set s equal to 0. So for s-intercept, we plug in 0 for y. I have -3 minus 2x equal to 3 times x. -3 minus 2x equal to 3 times 0. Then simplify. 3 times 0 is 0. 3 times 0 is 0. We leave the rest the same. -3 minus 2x. Then we try to get x by itself. In order to get x by itself, we try to eliminate -3 first, then eliminate -2. So I can add 3 to both sides. I have on the left side positive 3, -3 get cancelled. We have -2x by itself. On the right side, 0 plus 3 is 3. Then in order to get s by itself, I divide both sides by -2. On the left side, -2 on the top and the bottom get cancelled. We have x by itself. On the right side, 3 over positive 3 divided by -2. These numbers are not divisible. Positive 3 divided by -2, that's not divisible. But we know positive number divided by negative number is negative. 3 divided by 2 is not divisible. I leave it the way it is. And we know 3 over 2 can be rewritten as 1.5 if I convert to mixed number. If I convert 3 over 2 to mixed number, 3 over 2 represents 1.5. That's the x-intercept. For the y-intercept, we set s equal to 0. Plug in 0 for x. We have -3 minus 2x equal to 3y. Plug in 0 for x. We have -3 minus 2 times 0 equal to 3y. Then simplify the left side. On the left side, 2 times 0 is 0. On the left side, 2 times 0 is 0. Negative 3 minus 0 is negative 3 equal to 3y. In order to get y by itself, I need to divide both sides by 3. Then on the right side, positive 3 and positive 3 on the top and the bottom get cancelled. We get y by itself. On the left side, negative number divided by positive number is negative. 3 divided by 3 is 1. So that's the s-intercept, that's the s-intercept, and that's the y-intercept. Based on the intercept, let's sketch the graph. Draw the coordinate plane first. Number in the middle is 0. Numbers from the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then plot the s and y-intercept. S-intercept is negative 3 over 2. And we know 3 over 2 is 1.5. So 1.5 somewhere between 1 and 2. Negative 3/2 is somewhere between negative 1 and negative 2. That's an s-intercept. Negative 3/2. 3/2 is 1 over 2. Negative 1 over 2 is somewhere between negative 1 and negative 2. Y-intercept is negative 1. It's here. So this point, s-intercept, we label as negative 3 over 2 comma 0. For s-intercept, y-coordinate is always 0. For the s-intercept, the y-coordinate is always 0. For s-intercept, so that's s-intercept. For s-intercept, the y-coordinate is always 0. For the x-intercept, the y-coordinate is always 0. For the y-intercept, its s-coordinate is always 0. For the y-intercept, its s-coordinate is always 0. So this point can be represented by 0, comma, negative 1. Then by connecting 2 points, we can make a line. By connecting 2 points, we can make a line here. By connecting 2 points, we can make a line. So the s-intercept is negative 3 over 2, comma 0. Y-intercept is 0, comma negative 1. In general, when we represent points, we don't use mixed number, we use improper fraction. In general, when we represent points on the coordinate plane, we don't use mixed number, we use improper fractions in general. We use improper fractions. We don't use mixed number for points on the plane. So that's the line represented by these equations. Next, 4x equal to 3y. Next, 4x equal to 3y. We try to graph the line that represented by this equation. We try to graph the line that represented by this equation. So in general, to graph a line, we need 2 points. To graph a line, we need 2 points. Any 2 points. We prefer to use the x and the y-intercept. We prefer to use the x and the y-intercept. So for the s-intercept, we set y equal to 0. For the s-intercept, we set y equal to 0. For the y-intercept, we set s equal to 0. Let's try to find s-intercept first. I substitute 0 for y, solve for x. 4x equal to 3 times 0. Substitute 0 for y, solve for x. 4 times x stays the same. 3 times 0 is 0. In order to get s by itself, I divide both sides by 4. Then on the left side, number 4 on the top and the bottom get cancelled. We get s by itself. On the right side, 0 divided by 4 is 0. That's the s-intercept. S-intercept is 0. For the y-intercept, I plug in 0 for x, solve for y. I have 4 times 0 equal to 3y. 4 times 0 is 0. In order to get y by itself, I divide both sides by 3. Then on the right side, 3 on the top and the bottom get cancelled. I get y by itself. On the left side, 0 divided by 3 is 0. So the y-intercept is also 0. If we try to sketch the graph, how it looks like. If we try to sketch the graph, s-intercept is 0. Let's draw the coordinate plane first. S-intercept is 0. That means it touches 0 in the s-axis. S-intercept is 0. That means it touches 0 in the s-axis. Y-intercept is also 0. That means it touches 0 in the y-axis. So these 2 points actually go together. These 2 points actually go together. S-intercept is 0, 0. S is 0, y is 0. Y-intercept is also 0, 0. S is 0, y is 0. So they are on the same point. Now that's a special case. That's a special case. If the s-intercept and the y-intercept is the same, we must find a different point. If s-intercept and y-intercept is the same, we can't graph the equation. We can't graph the line using only one point. We need to find a different point. If they are the same, we count this as one point. If they are the same, we count this as one point. We can't graph a line with one point. Passing through one point, we can graph infinitely many lines. So that's not enough. Passing through one point, we can graph infinitely many lines. So we can't graph a line with only one point. We need to find a different point. We need to find a different point. To find a different point, you can substitute any number for x and y. To find a different point, you can substitute any number for x and y. So let's make it easier. If I substitute, for example, if I substitute s equal to 3, for example, if I substitute s could be any number. To make it easier, if I substitute s equal to 3, I have 4 times 3 equal to 3y. Then 12. 4 times 3 is 12. 12 equal to 3y. In order to get y by itself, I can divide both sides by 3. Then on the right side, positive 3, negative 3 get cancelled. We get y by itself. In the left side, 12 divided by 3 is 4. Y is 4. That's a point 3, 4. That's a point 3, 4. Then the reason I chose 3 is I can make an answer a little easier. 4 times 3 is 12. 12 divided by 3 will be whole number. But theoretically, you can pick any number for x. You can choose any number for x, then solve for y. Then plot this point. There will be a different point. You can get a same graph. So when s-intercept and y-intercept is the same, we have to find a different point. When the s-intercept and the y-intercept is the same, we need to find a different point. In order to find a different point, we can set x or y equal to any number. Whichever you think is easier for you. You can set x or y equal to any number. Then find a different point. Based on these 2 points, you can graph a line. First point is 0, 0. First point is 0, 0. A different point, we can use 3, 4. That means x coordinate is 3, y coordinate is 4. X coordinate is 3, Y coordinate is 4. Then by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. By connecting 2 points, we can make a line. But someone may ask, what if we choose a different value for x? Do we get the same graph? Someone may ask, you may want to ask, what if I choose a different value for x? Do we get the same graph? Let's try. If we choose a different value for x, do we get the same graph? Let's try. If we pick different value for x, do we get the same graph? So say this, say pick different value for x. Say if I let x equal to 6, for example, let x equal to 6. Then I substitute 6 for x, solve for y. I substitute 6 for x, solve for y. I have 4 times x is 6, equal to 3y. 4 times 6 is 24. Then to get y by itself, I divide both sides by 3. So on the right side, positive 3 on the top and the bottom get cancel. 24 divided by 3 is a. So this point here is 6, a. This point is 6, a. Then sketch the graph. So 0 in the intersection here. Intersection is 0. Number to the right are positive. So S and Y intercept is 0, 0. That's here. A different point on the graph is 6, a. X coordinate is 6, Y coordinate is a. So that's the point 6, a. By connecting 2 points, we can make a line. Connecting 2 points, we can make a line. And we can see that these 2 lines looks almost the same shape. These 2 lines looks almost the same shape. So no matter what we choose for x or y, once I find a different point, the graph always looks the same. No matter what value we choose for x and y. No matter what we choose for x and y. The graph we have must be the same. You can pick any value for x, pick any value for y. The graph is always the same. Next, let's look at a special case. Y equal to -2. This equation is very special. It only contains y, but no x. Usually in the previous example, the equation contains both x and y. This equation is a little different. It only contains y. That's a very, very special case. In this situation, choose any 2 value for x. We can pick any 2 value for x. That's a very, very special case. This equation only depends on y, no x. So in this situation, if s is missing, pick any 2 value for x. Pick any 2 value for x. One positive, one negative. So let x equal to pick any 2 value for x. One is positive, one is negative. So I pick x to be -3. Let x equal to +2. Pick any 2 values for x and for x. Usually pick one positive number, one negative number. If I let x equal to -3, y is always -2. So I have point -3, comma -2. If I pick x to be -3, y is always -2. So I have a point -3, comma -2. If I pick x to be 2, y is always -2. So I have a point 2, comma -2. That's a very special case. We pick two values for x, but y stays the same. Y is always -2. Y stays the same. Y is always -2. We pick two different values for x. Y always the same. Now we have 2 points. By connecting these 2 points, we can make a line. We plot these 2 points, then connect 2 points, we can make a line. Zero in the middle, number to the left, number to the right are positive. Number to the left are negative. Number above 0 are positive. Number below 0 are negative. So first point, -3, comma -2. X is -3, y is -2. That's the point here. -3, comma -2. X is -3, y is -2. Second point, x is 2, y is -2. That's the second point. X is 2, y is -2. So we have 2, comma -2. That's the second point. Then by connecting 2 points, we can make a line. This is a line represented by these equations. That's the line represented by these equations. Next, let's try to graph the line represented by x equal to 3. Next, let's try to graph the line represented by x equal to 3. Now that's also a special case. This equation only contains x, but not y. This equation only contains x, but not y. In this case, we pick any two values for y. Pick any two values for y. Usually one positive, one negative. Pick any two values for y. So let y equal, for example, y equal to -2, and let y equal to +3. Pick any two values for y. Say y equal to -2, y equal to +3. Then in this situation, x is always equal to 3. We have 3, comma -2. X is always 3. We have 3, comma -2. X is always 3. From the second point, we have 3, comma 3. So x is always 3. But y is -2 from the first point. Y is 3 from the second point. Now we got 2 points. Plot 2 points and connect 2 points, we can make a line. Plot these 2 points first, then connect 2 points, we can make a line. Let's draw the coordinate plane first. 0 in the middle, number to the right are positive. Number to the right are positive. Number to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Then plot both points. By connecting 2 points, we can make a line. First point, 3, comma -2. X is 3, y is -2. X is 3, y is -2. So this point is 3, comma -2. The other point, x is 3, y is 3. X is 3, y is 3. That's the point, 3, comma 3. Then by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. That's the line represented by this equation s equal to 3. Now, let's observe example 5 and 6. Let's observe example 5 and 6. Example 5 is the equation y equal to a constant. 6 is the equation x equal to a constant. When the equation has the form y equal to a number, its graph is always a horizontal line. And we see that when the equation has the form s equal to a number, the graph is a vertical line. The graph is a vertical line. So you see that when equation is in the form of y equal to -2, the graph is a horizontal line that goes through -2. When the equation is y equal to -2, the graph is horizontal line that goes through -2 in the y-axis. When the equation is y equal to -2, the graph is a horizontal line that goes through -2 in the y-axis. This is the y-axis. The graph is a horizontal line that goes through -2 in the y-axis. If the equation is in the form of s equal to 3, the graph is a vertical line that goes through number 3 in the s-axis. When the equation has the form s equal to 3, the graph is a vertical line that goes through number 3 in the s-axis. So keep it in mind. Note. A horizontal line always has the form of y equal to some number, say y equal to b, let b represents a number. A vertical line always has the form of s equal to a, where a is a constant, is a number. So y equal to a number is always a horizontal line. The equation x equal to a number always represents a vertical line. The equation y equal to some constant, y equal to some number always represents a horizontal line. The equation x equal to some number always represents a vertical line. Those are two special cases. Next, I want to show you a different way to graph linear equations. So first of all, let me show you a special formula, a special form of a linear equation. This form is called slope-intercept form. This form is called slope-intercept form of a linear equation. It looks like this: y equal to mx plus b. An equation in this form is called slope-intercept form, where m is called a slope, b is called a y-intercept. For any equation in this form, m is called the slope, b is called the y-intercept. So m is called the slope, b is called the y-intercept. For any equation in this form, m is called the slope, b is called the y-intercept. So this form, that's why this form is called slope-intercept form. For any equation in this form, m is called the slope, b is called the y-intercept. That's why this form is called slope-intercept form. Now let's do some simple example first. Find the slope and the y-intercept. For the lines represented by the given equations. Find the slope and the y-intercept represented by the lines. Find the slope and the y-intercept from the lines represented by the given equations. First of all, if I give you an equation, y equal to negative 3x plus 5, can you tell what's the slope, what's the y-intercept? Let's try to match this equation with the slope-intercept form. Can you tell what's m, what's b? If you compare these two forms, can you tell what's m, what's b? So if you compare these two forms, you can see that negative 3 represents m, and positive 5 represents b. You can see that negative 3 represents m, positive 5 represents b. So we say slope is negative 3, y-intercept is 5. Y-intercept is 5. But remember, y-intercept is a point. Y-intercept is a point at which the s-coordinate is always 0. For y-intercept, its s-coordinate is always 0. This point is called y-intercept. For the y-intercept, it's a point on the y-axis. So for the point on the y-axis, the s-coordinate is always 0. So we need to write y-intercept as 5 is as 0, 5. Because for the point in the y-axis, its s-coordinate is always 0. So we write 0, 5. Next example, y equal to 2x minus 4. What's the slope, what's the y-intercept? We try to match this formula with this equation. Try to match these two equations. Can you tell what's m, what's b? Try to match the equation. Can you tell what's m, what's b? Here we can see that m is 2, slope is 2. M is 2, that means slope is 2. Y-intercept is negative 4. B is negative 4. If you try to match the formula, you can see that B is negative 4. So y-intercept is negative 4. For y-intercept, we write it as a point 0, negative 4. For the y-intercept, s-coordinate is always 0. So we write 0, negative 4. Next, y equal to 3x. What's the slope? What's the y-intercept? What's the slope? What's the y-intercept? So if you try to match these two forms, you can see that 3 match m, but what's b? If something is missing, add 0. If something is missing, add 0 here. If something is missing, add 0. So we can tell slope is 3, y-intercept is 0, 0. Y-intercept is 0, but for a point in the y-axis, s-coordinate is always 0. For the point in the y-axis, s-coordinate is always 0. So we write 0, 0. This 0 comes from here. This 0 is always 0. For the point in the y-axis, the s-coordinate is always 0. The first place is always 0. The second place depends on the isolated number. The second place depends on the isolated number, depends on this number at the end. So that's the slope, that's the y-intercept. Next, y equal to 4. Y equal to 4. What's the slope? What's the y-intercept? This equation doesn't look like this. There's no x here. There's no x here. This equation doesn't have x, but slope-intercept form contains x. If there is no x, we write 0x by itself. We write 0x in the front. If the equation doesn't have x, we write 0x in the front. Then try to match the form. We can see that m is 0, b is 4, m is 0, b is 4. So the slope is 0, m is 0. Y-intercept is 0, 4, b is 4. So for y-intercept, we write 0, 4. Its x-coordinate is always 0. For y-intercept, its x-coordinate is always 0. Next. 3x minus 4y equal to a. How do we find the slope and the y-intercept? 3x minus 4y equal to a. This equation doesn't look like this form. So, in order to find the slope and the y-intercept, we must rewrite the equation. This equation doesn't look like this form. In order to find slope and the y-intercept, we must rewrite the equation. So let's rewrite the equation first. To rewrite the equation, we must get y by itself. Put it in the form of y equal ms plus b. So let's rewrite the equation, put it in this form, which means I need to get y by itself. So I need to eliminate 3x first, then eliminate negative 4. I get y by itself. So first of all, I subtract 3x from both sides. On the left side, positive 3x cancels negative 3x. We have negative 4y left. That's the left side. On the right side, a and negative 3x, they cannot be combined. So leave both of them the same. A minus 3x. We have a minus 3x. But if we compare a minus 3x with this equation here, this equation has x in the front, x in the first term here. But our equation, we have x in the second term. It doesn't match. So I need to reverse the order. I need to put negative 3x in the front, put number a in the back. I want to put x in the front. So I write negative 3x first, write positive a on the back. I want to put x in the front and a constant on the back. Then, in order to get y by itself, I need to divide negative 4y by negative 4. If I divide one term by negative 4, I need to divide every term by negative 4. If I divide one term by negative 4, I need to divide every term by negative 4. So after division, negative 4 divided by negative 4 can cancel, we get y by itself. On the other side, negative 3x divided by negative 4. When we divide, negative number divided by negative number become positive. Then 3 divided by 4 is not divisible. I leave it the way it is. And write x on the side. 3 divided by 4 is 3 over 4. Keep it in the front. Write x on the side. 3 over 4x. Then positive a divided by negative 4. Positive a divided by negative 4 is negative 2. Positive a divided by negative 4 is negative 2. Then by matching the formula, now try to match the formula, we can tell slope is 3 over 4. Y-intercept is negative 2. So I can tell the slope is 3 over 4. y-intercept is 0, 2. For the y-intercept, the s-coordinate is always 0, and -2 is the y-intercept. For y-intercept, the s-coordinate is always 0, and the y-coordinate is -2. Next, find the slope for the equation x equal to 3y minus 6. Find the slope for this equation x equal to 3y minus 6. So in order to find the slope, we must match the equation with this form. We try to get y by itself. Try to get y by itself first, then try to match what's m, what's b. Try to get y by itself first, then try to match what's m, what's b. Try to get y by itself first. So here, in order to get y by itself, I need to eliminate -6 first, then eliminate 3 in the front. Let me eliminate 6 first. Add 6 to both sides. So on the right side, positive 6 and -6 can cancel. We get 3y by itself. On the left side, we have x plus 6. Then, in order to get y by itself, I divide every term by 3. On the right side, you can see that number 3 can cancel. We get y by itself. On the left side, x divided by 3. So if there's no coefficient, no number in the front, we assume the coefficient is 1. X is always the same as 1 times x. If there's no coefficient in the front, we assume there's number 1 in the front. Then let's divide the numbers. 1 divided by 3 is not divisible. I leave it as 1/3. Put x on the side. X over 3 is 1/3 of x. 1 divided by 3 is not divisible. I leave it the way it is. Then put x on the side. Don't put x on the numerator. Put x on the side. Don't put x on the numerator. Put x on the side. Then 6 divided by 3 is 2. 6 divided by 3 is 2. Now we try to match this equation with this equation. We have y by itself. mx plus b. M is the number in front of x. That's m. And b is the number by itself. That's b. So we can tell that the slope is 1 over 3. And the y-intercept is 0, 2. Y-intercept is 0, 2. For the y-intercept, s-coordinate is always 0. And the number by itself is the y-coordinate. So we have 0, 2. The y-intercept is 0, 2. For y-intercept, the s-coordinate is always 0. Next, 3 times y minus 1 equal to 4 times x plus 2. We try to find the slope and the y-intercept. In order to find slope and the y-intercept, we need to match the equation within the form y equal to ms plus b. I need to rewrite the equation in its form first, then try to match what's m, what's b. Let's rewrite the equation first. When you see a number in front of parentheses, distribute the number first. When you see a number in front of a parentheses, distribute the numbers first. If I distribute 3, I get 3y minus 3. 3 times y, 3y. 3 times 1 is 3. If you see number 4 in front of parentheses, distribute number 4. I have 4x plus a. 4 times x is 4x. 4 times 2 is a. Then I try to get y by itself. That means I need to eliminate -3 first, then eliminate positive 3 in the front. Let's eliminate -3 first. I can add 3 to both sides. If I add 3 to both sides, on the left side, positive 3 and -3 can cancel. We get 3y by itself. On the right side, I have positive a plus positive 3, that's 11. 4x stays the same. Then in order to get y by itself, I divide everything by 3. Divide every term by 3. So on the left side, number 3 on the top and the bottom can cancel, I get y by itself. On the right side, 4 divided by 3, that's not divisible, I leave it the way it is. Write x on the side, don't keep it on the top, write x on the side. We want to match this form, so write x on the side. We want to match this form here. Don't keep x on the top. Don't keep x on the top, write x on the side. Plus 11 over 3 is not divisible, so I leave it the way it is. So if I match the form here, I can tell m is 4 over 3, m is 4 over 3, and b is 11 over 3. b is 11 over 3. That's my m, that's my b. So my slope is 4 over 3. My y-intercept is 0, 11 over 3. For the y-intercept, s coordinate is always 0. And the constant, this constant here, 11 over 3, is the y coordinate. For the y-intercept, s coordinate is always 0. And this number 11 over 3 is my y coordinate. Next. Three times x minus 2 plus equal to 4 times y plus 1. 3 times x plus 2 equal to 4 times y plus 1. In order to find the slope and the y-intercept, we must rewrite the equation in this form, get y by itself, then try to match what's m, what's b. So let's simplify the function first. Simplify the equation first. When there's a constant in front of a parenthesis, when we see something in front of a parenthesis, distribute first. When we see something in front of a parenthesis, distribute first. If I distribute 3, I have 3x. 3 times x is 3x. 3 times negative 2 is negative 6. Distribute 4. 4 times y is 4y. And 4 times 1 is 4. Then we try to get y by itself. Next, we try to get y by itself. So I can subtract 4 from both sides. On the right side, positive 4 and negative 4 can cancel. We have 4y by itself. On the left side, 3x stays the same. If I combine like terms, negative 6 plus negative 4. If I combine like terms, negative 6 plus negative 4 is negative 10. When I combine like terms, keep the sign, follow addition rule. When we add in two numbers of the same sign, keep the sign, add the magnitude. 6 plus 4 is 10. When we combine like terms, follow addition rule. If two numbers have the same sign, keep the sign, add the magnitude. 6 plus 4 is 10. Next, we try to get y by itself. So I can divide both sides by 4. So when I divide one term by 4, I divide every term by 4. So on the right side, I get y by itself. On the left side, 3 over 4, that cannot be divided. That's not divisible. I leave it the way it is. 3 over 4, that's not divisible. I leave it the way it is. Negative 10 divided by 4. Number 10 divided by 4. That's not divisible. I can simplify. I can divide the top and the bottom by, and the bottom by 2. Make 5 over 2. 10 divided by 4 is not divisible, but I can simplify the fraction. I can divide the top and the bottom by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. So if I try to match this equation with this form, I get y by itself. Mx plus b. So my m is 3 over 4. My b is negative 5 over 2. If I try to match these two forms. If I try to match this equation with this equation, we can see that my m is 3 over 4. My b is negative 5 over 2. So my slope, m represents slope. My slope is 3 over 4. M represents slope. My slope is 3 over 4. My y-intercept is negative 5 over 2. My y-intercept is negative 5 over 2. But y-intercept is a point in which the x-coordinate is always 0. So x-coordinate is always 0. Y-coordinate is negative 5 over 2. Now we know how to find the slope and the y-intercept. Now we know how to find slope and the y-intercept. Next, I'll show you how to sketch graph using the slope and the y-intercept. Next, I'll show you how to graph a line using the slope and the y-intercept. Next example. Graph each of the following lines. Graph each of the following lines using slope and the y-intercept. Graph each of the following lines using slope and the y-intercept. First line, y equal to 3 over 2x plus 1. First line represented by the equation. First line represented by this equation, y equal to 3 over 2x plus 1. In order to graph it with slope and y-intercept, we first of all find the slope and the y-intercept first. So try to match the equation. Try to find out what's the slope, what's the y-intercept. If I try to match here, I can see that my slope is 3 over 2. My slope is 3 over 2. My y-intercept is 1. My y-intercept is 1. So for y-intercept, write it as 0, 1. For the y-intercept, x-coordinate is always 0. Write it as 0, 1. My slope is 3 over 2. But remember, slope represents rise over run. Slope represents rise over run. Now let's graph it. Based on this information, let's graph a line. Let's draw the coordinate plane first. 0 in the middle, number to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Let's first of all plot the y-intercept. Y-intercept is 0, 1. That means it goes through number 1 in the y-axis. And this point is 0, 1. Y-intercept is 1, means it goes through 1 in the y-axis. And this point is 0, 1. For the point in the y-axis, x-coordinate is always 0. Then we try to find another point based on the slope. Next, we try to find another point based on the slope. Slope is 3 over 2, means rise over run is 3 over 2. So the rise is 3, run is 2. Rise is 3, means I go up by 3 units. 1, 2, 3. Rise is 3, run is 2, means I go 2 units to the right. this point is here, rise over long. So originally the y coordinate is 1. If I go up by 3 units, it becomes 4. So my y coordinate is 4. My s coordinate is originally 0. When I go 2 units to the right, it becomes 2. So that's the coordinate of the new point. Connect 2 points, we can make a line. So that's how we sketch graph using slope and the y-intercept. Another example, y equal to 1 over 4x minus 2. We try to graph this equation using slope and the y-intercept. So let's first of all find the slope and the y-intercept first. The equation is y equals ms plus b. The number in front of x is called a slope. So try to match. My m is 1 over 4. My b is negative 2. So the slope is 1 over 2, is 1 over 4. The y-intercept is negative 2. So I can tell that my slope is 1 over 4. My y-intercept, for the y-intercept, the s coordinate is always 0, and negative 2 is the y coordinate. For the y-intercept, s coordinate is always 0, the y coordinate is negative 2. Then let's graph the line based on information here. Slope represents rise over run. Slope represents rise over run. So let's draw the coordinate plane first. Number in the middle is 0. Number to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. So when we graph a line, plot the y-intercept first. When we graph a line, plot the y-intercept first. Y-intercept is 0 and negative 2. Y-intercept is negative 2 means it goes through negative 2 in the y-axis. That's the y-intercept. It's a point 0, negative 2. Y-intercept is negative 2 means it goes through negative 2 in the y-axis. And the point is 0, negative 2. Slope is 1 over 4. That means rise is 1, run is 4. Rise is 1. If we go up by 1, it go up to negative 1. Go up by 1. Then run is 4. Go 4 units on the right side. 1, 2, 3, 4. Go 4 units on the right side. That's the point here. Let's try to find a coordinate for this point. The y coordinate is originally negative 2. If you go up by 1, it becomes negative 1. S coordinate, it was 0. If we move 4 units on the right side, 1, 2, 3, 4, it becomes 4. So the new point is 4, negative 1. And by connecting 2 points, we can make a line. By connecting 2 points, we can make a line. By connecting 2 points, we can make a line. By connecting 2 points, we can make a line. So this is the graph of this line, of this equation. That's the graph represented by this equation. We graph it based on the slope and the y-intercept. Next, y equal to negative 3 over 2x plus 3. Y equal to negative 3 over 2x plus 3. In order to graph the line, let's find the slope and the y-intercept first. Try to match the formula. Find the slope and the y-intercept. If you try to match the formula, the number in front of x is negative 3 over 2, so natural slope. The y-intercept is number 3. If you try to match the formula, you can see that the y-intercept is number 3. So in the x-coordinate is always 0. For y-intercept, the x-coordinate is always 0. The y-coordinate is number 3. That's the y-intercept. Then for the slope, we try to use rise over long. If the slope is negative, we attach the negative sign to the top, to the numerator. So I write it as negative 3 over 2. So the rise is negative 3, long is positive 2. Then let's graph the line based on the slope and the y-intercept. Let's graph the line based on the slope and the y-intercept. Draw the coordinate first. 0 in the middle. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. So let's first of all plot the y-intercept. When we sketch graph, plot the y-intercept first. Y-intercept is positive 3, so the line goes through the point positive 3 in the y-axis. Y-intercept is 3, so the line goes through number 3 in the y-axis. And the coordinate is 0, 3. That's the coordinate of the y-intercept. Next, we use the slope to find a different point. Rise is negative 3. That means the graph goes down by 3 units. 1, 2, 3. Rise is negative 3, means the graph goes down by 3 units. Long is 2, means the graph goes 2 units to the right side. That's the destination. That's the destination point. For this point, let's find the coordinate for this point. The y-coordinate was 3, but if I go down by 3 units, it becomes 0. So the y-coordinate is 0. The s-coordinate it was 0, but since I moved 2 units to the right, it becomes 2. That's the new coordinate. That's the coordinate for the new point, for the second point. Then by connecting 2 points, we can make a line. Connect these 2 points, we can make a line. If I connect these 2 points, I can make a line. So that's the graph represented by this equation. That's the graph of the line represented by this equation. We graph this line using slope and the y-intercept. Next example. Y equal to negative 2x plus 1. Graph the line using slope and the y-intercept. So first of all, we try to match the equation y equal ms plus b. We try to match what's m, what's b. Y equal to mx plus b. We try to match what's m, what's b. So if I match these two equations, we can see that m is negative 2, b is 1. So the slope is negative 2. And the y-intercept is 0, 1. Remember, for y-intercept, s coordinate is always 0. y coordinate is b. For y-intercept, s coordinate is always 0. Y coordinate is b. Here is 1. Then slope is -2. -2 can be rewrite as -2/1. So -2 is the rise. Number 1 is the wrong. If the slope is negative, always attach negative sign to the numerator. Then sketch the graph. Sketch the graph. Let's draw the coordinate plane first. Number in the middle is 0. Number to the right are positive. Numbers to the left are negative. Numbers above 0 is positive. Numbers below 0 is negative. So plot the y-intercept first. Y-intercept is 1. That means it goes through 1 in the y-axis. Y-intercept is 1, means the graph goes through 1 in the y-axis. And the point is, the coordinate of this point is 0, 1. The coordinate of the y-intercept is 0, 1. Now, use the slope to find the second point. Next, use the slope to find the second point. Slope is -2/1, rise over long. Rise is -2, means we go down by 2 units. Rise is -2, means we go down by 2 units. Long is 1, means we go 1 unit to the right side. That's the second point. Now let's find a coordinate for the second point. Y was 1. If I go down by 2 units, the y coordinate becomes -1. My y coordinate was 1. If I go down by 2 units, it becomes -1. My s coordinate was 0. If I move it 1 unit to the right, it becomes 1. My s coordinate was 0. If I move it 1 unit to the right, it becomes 1. So that's the coordinate of the new point, 1, -1. By connecting 2 points, we can make a line. So that's the line represented by this equation, and we graph it using slope and the y-intercept. Next, y equal to 3x minus 4. First of all, try to match what's the slope, what's the y-intercept. If I match this equation with this form here, we can see that m is 3, b is -4. So my slope is 3. My y-intercept is 0, -4. For the y-intercept, s coordinate is always 0. Y coordinate is always b. Here, b is -4. Then slope is -3. That can be rewrite as 3/1. Slope is 3. That can be rewrite as 3/1. So 3 represents rise. 1 represents long. Then graph the line. Let's draw the coordinate plane first. Number in the middle is 0. Numbers to the right are positive. Numbers to the left are negative. Numbers above 0 are positive. Numbers below 0 are negative. Y-intercept is -4. That means the graph goes through -4 in the y-axis. Y-intercept is -4. That means the graph goes through -4 in the y-axis, and the coordinate from the y-intercept is 0, -4. The coordinate is 0, -4. Slope is 3/1. That means rise is 3, run is 1. So rise is 3, run is 1. Rise is 3, go up by 3 units. 1, 2, 3. Run is 1. I go 1 unit to the right. That's the second point on the line. So let's find the coordinate first. The y coordinate, it was -3. If I go up by 3 units, 1, 2, 3, it becomes -1. So the y coordinate is -1. My s coordinate was 0. If I move 1 unit to the right, it becomes 1. That's the coordinate of the second point. Then by connecting 2 points, I can make a line. And this is the line represented by this equation. We graph the line using slope and the y-intercept.